So the words rate of change, mathematically when you see those words, what should you think of? Slope, okay? Slope. And so the way that or the slope that you understand and that you have known how to do forever is not the only kind of slope. What that is if it's linear, then that is a constant rate of change. Constant rate of change. Because the rate of change stays the same for the entire line, right? We are going to talk about average rate of change, which is different than just the slope of a line. We have already talked about instantaneous rate of change. I just didn't use those words. So on Monday, when we did the tangent lines and the difference quotient, we found the slope of the tangent line at a point. So with the curve, the rate of change changes constantly, right? So what's constant about that is that it's changing constantly. So the rate of change changes as things increase, decrease, and whatnot. So when we found the slope of the line tangent at that point, that's the instantaneous rate of change at that specific point. It would be different than the rate of change at this point, or at this point, or so forth. Does that make sense? Okay, so what we did, so we've already done the instantaneous. We already knew how to do the constant. We actually did the average already. Like I said, we just didn't kind of call them that. If we can't find the slope of the tangent line, we can approximate it with the slope of the secant line. Okay, and that's where your average rate of change comes in. And depending on why you need to know the slope and what you're going to do with it, that's what changes like what you're interested in, instantaneous or average or constant, whatever. So let's, first of all, take a trip back in time to pre-algebra and talk about basic slope. Okay, so if I want the slope of this line, one of the reasons that it's constant is I can pick any 2 points in the universe that are on that line, and there's an infinite amount of them. Any 2 of them should give me the exact same answer if I do it right. So they've already marked these 2 points for us. If we have a graph, we can easily just count rise over run. So I would go up 1, 2, 3, and over 1, 2, 3, 4. So that's 3/4. Right? Should be a piece of cake. What is the slope of the line in this picture? Y'all going to calculus next year? Yeah. I've had crickets all day when I've asked this question. So at lunch, I jokingly asked Mr. Ackerman, so Mr. Ackerman, in calculus, do you have to know what the slope of a horizontal line is? And he was like, yes. Not only do you have to know what the slope of a horizontal line is, you have to know what the slope of a vertical line is, which once again, guys, is pre-algebra. That is not something that can stump you, like it's the hardest question ever, and you cannot get them mixed up. Okay? So, if I was going to teach you slope from scratch, which I totally am not, and when I would reteach it in geometry, we would always go through a little lesson with something that looked like this. And we'd draw little skiers on it. So let's pretend we're going snow skiing. Okay? If I'm going to have to ski up the mountain like that, that's going to not be a whole lot of fun. So I would say, oh, poor me, that's a positive slope. If I got to ski down the slope, that's why I went skiing in the first place, so that's nice. So nice is negative. If I'm skiing on this slope, it's not as bad as going uphill, but probably not why I spent all the money to go skiing, right? Now there is cross-country skiing. Some people enjoy that, like some people enjoy cross-country running. I don't get it. It's not for me. But still probably not why you go to the ski resort, right? So even though you can ski on this, it's no fun, so it is 0 fun. When you keep skiing and there's a cliff, there is literally nothing for you to ski on. It does not exist. It is completely undefined, and so your vertical line, undefined slope. You cannot let that hold you up for even a split second. When you see something like this, you should be able to say the slope is 0. End of story. All right, so now we are going to look at between the 2 points. Again, reviewing pre-algebra here. When you learn slope, you learn that it is, actually you learn the formula first, but big boy and girl way to do it, delta y over delta x. So it's just the change in y over the change in x. So that's going to give me negative 7 minus 3 over negative 5 minus a negative 9. So that's going to give me negative 10 over 4. So that slope is negative 5/2. Is slope really easy to find? Yes. Is it also really easy to mess up? Yes. What usually causes you the most problems? The signs, right? Okay, it's not that you can't add and subtract, this is the signs do, and probably because you're not writing stuff down and whatnot. So you do number 5, find the slope between those 2 points. Let's make sure we can all actually do it. You get that the slope is 1/3. Do we agree with that? Okay, good deal. All right, so now let's talk about average rate of change. Okay, average rate of change. For functions, and this really should say for linear functions, for linear functions, the slope is constant between each pair of points, any 2 points you pick. For non-linear functions, the slope changes between different pairs of points. Okay? So like I said before, if we're looking at this parabola, and as it's increasing then decreasing, the rate of change changes throughout the entire thing, right? So we can find then, instead of instantaneous rate of change, like the slope of the tangent line, we can find the average rate of change, which sometimes that might be all you really need to know, depending on, again, how we're actually applying this. So it says the average rate of change of a function between 2 points is the slope of the line that passes through these points. This is called a secant line. So we talked about tangent lines and secant lines on Monday, so I'm not going to redraw all that stuff, but it's a secant line because it intersects at 2 points here. So the formula for this would look like this. All right, well, if this is A, so my x value, then for this point, the y value would be f of A. If this is B, then the y value for that point would be f of B, because that's how you calculate it, right? It's like x and f of x. So the slope of the secant line, so it's a little subscript SEC for secant, so slope of the secant line, is equal to, it's still just the slope of a line, so it's the change in y over the change in x. It's f of B minus f of A over B minus A. The change in y over the change in x. All right. So then we have here, it says, given the function graph below, find the average rate of change on each interval. So it's giving me an interval, not an ordered pair, because it's in brackets. That's what makes it an interval. So I want the slope of the secant line, and that would mean that this is A and this is B. So f of B, that would be f of 1 minus f of A, which is negative 2, over B minus A, which is 1 minus a negative 2. Okay? In order to find that, I have to know what f of 1 and what f of negative 2 is. What is f of 1? It's negative 8. Yep. Negative 8. And then what is f of negative 2? 1. Okay. So now that I got my two pieces, that means that that gives me negative 8 minus 1 over 3. That's negative 9 over 3. So the slope of the secant line on that interval is negative 3. Any questions about that? Easy enough? Same, like the slope formula is the same. It's the concept of what you're actually finding is what's different. So these were my 2 points right here. So the average rate of change from here to here, I mean, you can see that the rate of change changes, but it doesn't change super drastically, right? So this right here, the slope of this line would be the average rate of change, and it would be a pretty good estimate of what the rate of change throughout that would be. Okay, we good? Easy enough? All right. Let's jump to number 9. So once again, I'm going to find the average rate of change on this interval. Right, so the slope of that secant line is going to be f of b, which is negative 7, minus f of a, which is negative 9, over negative 7 minus a negative 9. Right? So I need to find each one of those things. I need to find f of negative 7. How do I find that? Substitute it in. So 2 times negative 7 squared plus 28 times negative 7 plus 93. Okay, I put calculators back on your table. I want you to actually type that in, because some people are having issues with getting the right numbers out of the calculator. So let's make sure what? Oh, there's only one. I'm sorry. Negative 5. Good. So then I also need f of negative 9. That's equal to 2 times negative 9 squared plus 28 times negative 9 plus 93. Now on these calculators, if you just use that big blue button and arrow up, it should let you go edit the function, and you could probably just go change your negative 7s to negative 9s, so you don't have to retype all that mess. Or you can retype it. I mean, it doesn't matter either way. 3. Good. Okay, so now that I have those two things, I can come back over here and finish this. So that is equal to negative 5 minus 3 over 2. So the slope of the secant line is going to be equal to negative 4. Any questions at this point? All right. I don't think we need to do a ton of examples, but we are going to go do number 12. But put the calculators aside for this one. We're going to do the rest of what we're doing without one. So I want the slope of the secant line. My interval is from negative 1 to 7. So that means I'm going to have f of 7 minus f of negative 1 over 7 minus a negative 1. So over here, I will do f of 7. That's going to be the square root of 7 plus 5, which is the square root of 12. And without the calculator, what is the square root of 12? 2 squared root of 3. Very good. Okay, so then I need f of negative 1. That's equal to the square root, negative 1 plus 5. And that is 2. So I come back over here, and I'm going to get 2 square roots of 3 minus 2 over 8. Can I reduce the 2 and the 8? No. And if we think the answer is yes, you probably have no hope. What do I have to do in the numerator? Factor. 2 times the square root of 3 minus 1 over 8. Now you can reduce, and you end up with the slope of the secant line equaling the square root of 3 minus 1 over 4. Okay. Any questions? All right. Let's look at 13. A company's total cost, C of X in dollars, to manufacture X units is given by this equation. Find the average rate of change of the total cost for the first 200 units manufactured. All right. So what is my interval then? What'd you say? Close. Super close. What do we start with? 0. Be 0 to 200. All right. So my slope of that secant line is equal to, all right, so they're using C instead of X, so that's what I'm going to do. So I'm going to say C of 200 minus C of 0 over 200 minus 0. Okay. So I need to find C of 200. That's going to equal 0.5 times 200 squared plus 40 times, oh, it is, thank you, 0.05. There you go, yes, thank you. 0.05 times 200 squared plus 40 times 200 plus 1200. And I'm just going to tell you, since I told you to put your calculators aside, it's 11,200. Okay. Then, so I have 0.05 times 0 squared plus 40 times 0 plus 1200. What's that going to give me? 1200, right? Don't need a calculator for that for sure. All right, so now that I have all of that, come back over here, and I get 11,200 minus 1,200 over 200. So what's 11,200 minus 1,200? 10,000. So I have 10,000 over 200. You totally don't need a calculator for this. You can get, ooh. Oops. There you go. So we can knock out those zeros, so we just have 100 divided by 2, which is 50. However, we can't just be able to find 50 and have no idea what that even means. Sure, that's the slope of the secant line, but what does that tell us? The average rate of change. So what are my units? This is 50 what? This is a rate of change, right? So it's a rate. So it's 50, not percent, but it's like miles per hour. It's like a dollars per unit. Very good. $50 per unit. That's your average cost. For the first 200 units. And the idea, of course, is that the more units you produce, the lower that number will get, right? We good? Any questions? All right. So your assignment, I'm going to give you a piece of paper, but your assignment, I put it in formative also. That way you could go and check your answers. And I realize most of you don't, a lot of you don't have your tablet, so you don't have to put it in formative. I would think you would want to, so you can check yourself, but yeah, you might have to do that part on your phone.